All right, welcome to this explainer on why bringing robotics into the classroom is literally revolutionizing how kids learn, all the way from kindergarten up through high school. I am so incredibly excited to dive into this with you today because we're looking at a massive fundamental shift in education. We're talking about moving away from just staring at screens and reading textbooks and actually bringing logic, engineering, and pure creativity right into the physical world. So I want you to imagine this for a second. Imagine a classroom where kids are doing complex math and engineering, but they don't even realize it because the whole thing just feels like playing. When you introduce robots into that space, the vibe completely transforms. Suddenly, these abstract, boring concepts become really fun, tangible challenges. Students aren't just glued to their desks anymore. They're down on the floor, they're collaborating, testing things out, and having a blast. You know, we've all been there with traditional learning. It's usually a lot of passive memorization, listening to a lecture, taking endless notes, and just trying to cough up the one fixed answer for a test. But robotics? Robotics completely flips the script into an active, hands-on process of trial and error that sparks genuine curiosity. Instead of being handed a neat little solution, students are handed a goal. They have to physically build the answer themselves, which forces them to engage with the material on a way deeper level. Now, you might be thinking this is just for high schoolers, right? No way. Research actually shows that when we use the right, developmentally appropriate tools, even the absolute youngest learners can grasp some pretty complex computational ideas. Early childhood researchers have found that when kids get tools that encourage open-ended play, they just naturally cultivate this intense curiosity for the tech world. They start figuring out cause and effect and basic sequencing way before they can even read a single word of a textbook. So in today's explainer, we're going to quickly run through 6 key areas: rethinking how kids learn, building cognitive and STEAM skills, fostering resilience, boosting collaboration, driving inclusion, and finally, getting them ready for the future. Let's jump right into part 1, rethinking how children actually learn. Take a look at the students here. They are literally leaning into the lesson. In a really fascinating recent study at a German high school, students successfully learned about the human nervous system by having face-to-face, interactive dialogues with a humanoid robot named Pepper, which was actually powered by a large language model. This wasn't some rigid, boring lecture. The robot guided small groups through the material, broke it down into digestible chunks, and answered their random, spontaneous questions. It adds this physical, social dynamic to learning that a standard computer screen just absolutely cannot match. Moving right along to section 2, building cognitive and STEAM skills. So, how does this all start? Well, even in early childhood, educators are using screen-free robots, like Kibo, for example, that use physical wooden programming blocks. When little kids assemble these parts, they're not just playing. They're actively developing crucial fine motor skills and spatial awareness. And as they physically snap these blocks together to create a program, they are learning the exact sequencing logic that is completely foundational for both early math and reading comprehension. They are literally learning to code without ever looking at a screen. This hands-on process is basically a real-life visualization of the computational thinking loop. When kids are faced with a task, they learn to model the problem, break it down into tiny, manageable steps, invent a solution, and then test the whole thing out. And let's be honest, this step-by-step approach is exactly how real-world problem-solving works in science, in business, in everyday life. By physically programming a robot, these kids are training their brains to think computationally. Which brings us to section 3, problem-solving and resilience. Here is the absolute best part about all of this. In robotics, failure isn't a bad thing. Actually, scratch that. It's not even seen as a failure at all. It's just feedback. In the lab, a bug in the code, a wheel falling off, or a sensor acting up isn't a disaster that ruins your grade. Instead, it's immediate, valuable information. The students see exactly what went wrong right there in the physical world, and that immediate feedback guides their very next attempt. It completely shifts how they view making mistakes. This constant rapid-fire trial and error builds something known as algorithmic reasoning. Sounds super academic, right? But it's really just the ability to think in if-then sequences to logically solve a puzzle. Cultivating this kind of reasoning takes an enormous amount of patience, but children learn to persist, to tweak their code, and to troubleshoot over and over again. It builds a ridiculously resilient mindset that teachers see transferring directly into their other classes, like math and science. All right, let's look at section 4, collaboration and creativity. Now, here is where how we design the curriculum becomes a real game changer.
Traditional, rigid robotics usually rely on hard plastics and metals, and studies show this can sometimes accidentally reinforce gender roles, with boys taking over the design and girls kind of getting pushed to the sidelines. But when schools introduce soft robotics, using flexible materials and diverse designs, it heavily mitigates those gender differences. It drastically boosts girls' confidence in tinkering and their overall interest in engineering, which ensures everybody gets their hands dirty with the core tech. Plus, let's be real, building a robot is almost never a solo gig. Working in groups forces students to actually communicate. They have to assign distinct roles, share their wild ideas, and figure out how to resolve technical arguments without losing their cool. And beyond that, it is incredibly creative. They aren't just building clunky machines. They're blending storytelling with engineering, creating literal physical art through their designs. It's this beautiful mix of highly structured logic and total creative freedom.
And that leads beautifully into Section 5, inclusion for every single student. This is huge.
Recent special education research is showing us that different robots can serve vastly different, yet equally incredible, inclusive needs. They act as these super adaptable mediators. For example, humanoid robots have been wildly successful at helping kids on the autism spectrum develop critical social communication skills. For students dealing with severe motor impairments, robots like Zora are proven to improve play skills and even mobility functions. And for teenagers who are stuck at home due to severe illness, telepresence robots allow them to literally attend school remotely, which massively boosts their feelings of connection and peer empathy.
Now, you might be wondering, do kids actually accept having robots around? Well, when researchers evaluated this in that German high school study, the answer was a resounding yes. Both male and female students rated the competence of the robotic teaching assistant incredibly highly. They totally recognized the robot's ability to reliably give them information and genuinely help with their questions.
And just as importantly, the reported levels of discomfort were remarkably low. This really proves that, when it's done right, robots don't creep students out or alienate them. Instead, they can foster this incredibly safe, engaging, and welcoming environment for literally all types of learners, totally free from the social biases that can sometimes make human-to-human interaction tricky in a classroom. Okay, our final section, number 6, preparing for the future. So taking all of this in, what does this mean for the world waiting for these kids outside the classroom? Look, the reality is that AI and automation are radically changing the globe right now. By mastering these robotic tools early on, students are picking up a universal language of logic that totally breaks down cultural and linguistic barriers. They aren't just learning how to consume tech, they are learning how to build it, manage it, and fix it. This deep digital competency, paired with that awesome, resilient, analytical thinking they've developed, is exactly what they need for a modern, automated workforce. Which brings us to the end of our explainer. We've seen firsthand how robotics transforms education from passive memorization into joyful, active creation. It builds powerful cognitive skills, fosters tough resilience, champions real inclusion, and gets our kids ready for whatever the future holds. So, knowing all these amazing benefits, it leaves us with one pretty provocative question. Are we ready to give every single child the tools they need to build their own future? Thank you so much for joining me to explore this. Keep learning and keep building.